embedment of this seed pile to maintain the stability of this seed pile. Okay, now going to the derivation of D, that is the depth of embedment. Now first I'll show you the figure later. First see what are the primary consideration. Primary consideration is that we are considering the cohesive soil, purely cohesive soil. So purely cohesive soil, in the purely cohesive soil, phi is equals to 0. Okay. Now, first step of the design is to calculate the active earth pressure and passive earth pressure. That means lateral earth pressure. First step is to calculate gamma is the indicator of soil and H is the depth of the soil. Okay, and this is PP, that is the passive earth pressure, passive lateral earth pressure, where again KP is the coefficient of passive earth pressure and K is the coefficient of active earth pressure. Okay, so this is the basics. We have already studied this in the previous semester while you have studied the lateral earth pressure theory. Now Q is gamma H, C is the cohesion, all of you know that. Now coming to the next part. Next part is that K is nothing but tan square 45 dg plus 5 by 2. From that, yes, from that K is 1 minus sin phi and divided by 1 plus sin phi. The primary equation. From that this can be derived. Okay, and KP is 1 plus sin phi divided by 1 minus sin phi. Isn't it? Okay, now again considering the purely cohesive soil, phi is equals to 0, this equals to 0. That means K is equal to 0 and KP equals to 0. Sorry, 1. K is equal to 1 and KP equals to 1. Okay. That means most simple in case of cohesive soil. In the cohesionless soil, I'll discuss the cohesionless soil later. But in the cohesionless soil, K and KP will not be 0 because phi value will be there. Any of the phi value will be there. Okay. Now. Next step, please ask if you are not getting. There is a huge numerical derivation for this D. Okay, but when we consider some numerical values, then we can easily calculate the D. D is the main parameter which is to determine, which is to design for the sequential wall. Okay. Up to this, is it clear? This is the primary consideration, nothing else. That is to calculate K and KP and how to calculate passive earth pressure and active earth pressure. Now, if K and KP is 1 for cohesive soil, what will be the PA, small PA, that is the active earth pressure? From the equation, Q minus Q root over of Kp. From these, K is equals to 1, Kp is equals to 1. Put K and Kp is equals to 1, Q minus 2C, Q plus 2C. C A and Tp. Is that clear? Now come to the next. That is the E unit weight. This Q is nothing but gamma H, and this Q also nothing but gamma H. This is the overburden pressure. That means that if you remember the diagram of sheet pipe wall like this, so all these things are now for the time being for the this part, that means from the top of the excavation to the bottom of the excavation, or top of the filling to the bottom of the filling. That means above the dredge line. If this is DL and this is GL, then all these calculations are for above the dredge line. That means from these to these. So if H, let this height is H and unit weight is gamma, unit weight of the soil is gamma, then Q will be gamma H. This is the overburden pressure. Is that okay now? So Q is equals to gamma H, that means gamma H minus 2C, and Pp is equals to gamma H plus 2C. Is this clear? Okay. If this is clear, then coming to the lateral pressure at top of sheet pipe, that means, okay, I have this should be there. At the top, how much will be the active and passive earth pressure? We don't require the passive earth pressure now, because why? Because in this side there is no soil. Is there any part of soil up above the dredge line? So as there is no soil, passive earth pressure is not there. After the dredge line, in this side, soil is there. That's why passive earth pressure will coming into action. So above the dredge line, no passive earth pressure, only active earth pressure. I think all of you can remember the definition of passive and active earth pressure. Active earth pressure is when the wall is going away, far away from the backfill soil or the soil part. And passive earth pressure is when the wall is moving towards the soil or the backfill soil. That is the passive. When going away, that is the active. When going towards moving towards the soil, that is passive. the negative side. As this is the active side, negative active means in this side. No. So starting from the top of the excavation, the active earth pressure will be minus 2C, negative. Okay. If we go towards the bottom of the excavation, then obviously H value will be increased. From 0 it will be 1, 2, 3, 4, 5 like that up to the level of bridge line. All of you are getting that. So if we increase the value of H, then this part continuously increasing, and finally at if the depth is H, then some positive value will come. That means at this point, if we consider H is equal to H, then P is equal to 10 gamma H minus 2C. Okay, and in that case, this is the gamma H minus 2C. This part, no, a value. So if we join these points, this will be the active earth pressure diagram for cohesive soil, where this negative part is there. This is the basis of the retaining wall or earth pressure theory behind the retaining wall. No. So this is the first step or first part of the diagram, earth pressure diagram. We have to draw for the sheet-pile wall. Is that clear? Okay. So coming to the next part. So this is the active earth pressure at the top, that is minus 2C. Now one thing that is not recorded in the calculation, but for a definition, if we this that in PA gamma H minus 2C is 0. That means no active earth pressure. In that case, H is equals to 2C by gamma. Okay, this depth is called critical depth in case of retaining wall. But this is not the retaining wall. Actually, I have told you that this is not a permanent structure like retaining wall. This is a temporary structure. And this, yes.
If you are considering the soil,
Yes.
which is actual net for compaction, there will be tax.
For compaction.
After compaction, there will be tax.
Yes.
HM will be reached.
Actually, I am coming to that track part also. I will come into that track part, and what will happen if track is coming due to this negative earth pressure. Okay, due to this negative earth pressure, what will happen? This part of the soil will separate out. That is only the crack, na? That is only the crack. This part of the soil will separate out from this part of the sheet pile due to the negative pressure. No, that is only the crack, and if crack is coming, obviously you have to consider that crack also. Okay, if crack is coming, then this part of the pressure will not consider in the calculation. Only this positive part of the pressure will be considered in the calculation. Okay, I will go into that part also. Now before that, this is critical depth in case of retaining wall, which is the permanent structure. But sheet pile walls are not permanent up to this is the freestanding. That means if this is the wedge line, that 2c by gamma, that means this height of the soil can stand without the support of the retaining base or the sheet pile wall. Okay, so this is the concept. Now coming to the derivation part. Now the resultant force or thrust. What is resultant force of thrust for the lateral earth pressure? If this is the lateral earth pressure diagram, active earth pressure diagram, what is the resultant force or resultant thrust? Yes. Like this, earth pressure is acting now, either from left to right or from right to left. So total force, these are the pressure, these values are pressure, gamma h minus 2c, this is the pressure. Okay, now total force means total pressure acting throughout the wall, height of the wall or depth of the wall. Okay, so the area of this earth pressure diagram is the total thrust or total force acting on the sheet pile wall. Okay, so in this case of cohesive soil, as this H0, this is the 2c by gamma, freestanding height. Okay, and this H0 is there, and the Priyanshu, your answer of your question, that is, if cracks are formed, that means that tensile, that this part is under tensile condition, just tending to be separated from the sheet pile wall. In that case, the tensile cracks, this kind of cracks are called tensile cracks. Okay, tensile cracks are formed, and the pressure, negative part of the pressure, that will be released. Okay, that's why this part of the pressure we are not considering here, because pressure is released due to the formation of the cracks. Because at this part of the sheet pile wall, the soil, this soil want to be separated out from the sheet pile wall due to the negative pressure. Negative pressure means this side, and positive pressure is this side. From this to this side, negative pressure means this side. So this side means soil wants to move this way. That means want to separate from the sheet pile wall. So that's why this separation means crack. Two surfaces are separated out, that means cracks. These kind of cracks are called due to the formation of the cracks, the negative pressure is released. Okay, and that's why this part, the H0 height of the sheet pile wall, is not coming into the consideration, and that's why the P0, capital P0, that is the total force. Total force is nothing but half of the this area, half multiplied by base multiplied by height. This is the area of the triangle. Base multiplied by height multiplied by half. So this base is this one, gamma h minus 2c. This is gamma h minus 2c, no? So half gamma h minus 2c. This is the base, and height as the H0 part, freestanding part. In that part, the negative pressure is released. That's why H minus H0. This is the H0, that is 2c by gamma. Crack part. Okay. So the total force of total thrust is this. Is that clear? Okay. So this is the first force we have calculated, that is acting on the sheet pile wall. Rest of the the next part. Up to this, all these things are above the bridge line or from the top of the excavation to the bottom of the excavation. That is up to this part of the soil. Okay. Now coming to the dredge line and below the dredge line, the soil which is below the dredge line. That means this part. Okay. And in this part, what will be the scenario is that both sides of the six by wall there is soil. That means in this part, active earth pressure and passive earth pressure both will coming into action simultaneously. Okay, and due to the action of the cohesive soil, you should understand the deflected shape of the retaining wall. In the previous class, last class, I have shown you for the cantilever sheet pile straight. Deflected shape is a straight, only in some inclined angle. Okay, in the anchored sheet pile, there will be a curve. Okay, but in the cantilever sheet pile, there is a straight line, only inclined. Okay, so this point is the fixed point. That means around this point, center of the rotation is there. Okay, that means the cantilever sheet pile is rotated due to the action of all these active pressure and passive pressure. Passive pressure, active pressure, active pressure. Okay, and this will be the center of the rotation. Okay, that's why now you should understand there will be two parts. One is up to this, below the dredge line. I am talking about below the dredge line. One is above this point, another is below this point. Okay, so above this point, the retaining sheet pile wall is moving this way, this side. That means from right to left. Okay, so this part, for this part, active this side, passive this side. Is this okay? Away from the soil, this part away from the soil, and from this side towards the soil. So active pressure, this side passive pressure. But this part is moving towards this. That means in this part, active pressure is at this side and passive pressure will act in this side. Is this clear? Due to the rotation of the center of rotation of the sheet pile wall at this position. So above the point of rotation, active pressure this side, passive pressure this side. Below the point of rotation, active pressure this side, passive pressure this side. Because this part is moving towards this and away from this part of soil and towards this part of soil. Is that okay? If this part is okay, then 90% understanding is complete. Now determination of the lateral earth pressure below the dredge line. Below the dredge line, this part is active. Okay, let me draw the diagram clearly. active and this way passive. And below this way passive, this way active. Okay, now P0, you have noted down now what is P0? I think I have that questions also, no problem. Okay, now below the baseline, send small pa, that is This is the simple one. Is that clear? The operator diagram. So let's say to the diagram I have written in the presentation. This part is not considered, that's why not hatched. This was negative tension part is not considered, that's why not hatched. Okay, rest of the part is hatched because the pressures or forces are considered in the calculation. So total this part, this is the active thrust P0. P0 value is already calculated, no? This is the active thrust for this part of the pressure. This P2 is the active total thrust or total force for this part of the pressure. Okay. Yes. First one is Rupanji Dara. Now, coming to the final part, that is to derive the D. That is the depth of embedment. That is the primary design parameter for sigma equal.